do that. And so the idea is that there'll be the first evaluation due on the 7th, the sort of multiple evaluations due around the 21st, and then or on the 21st, and then the first pass at the final evaluation due by the 30th. And so in between now and then, there'll be a series of videos going up, and I'll continue to do these Wednesday night sessions. The 15th, I believe it is. Did I already tell you about the 15th? Yes, yes. The 14th. No, the 14th. We're fine. So we'll continue to do these sessions on every Tuesday night until the end of the semester, end of the summer session, and so you'll have a chance to ask any question you want to ask, and we'll try to provide an answer to that. And if you're having issues with JASP, we probably need to solve those pretty quickly, because we need to, you're going to have to use that as continually as we go forward. So any questions about any of that scheduling stuff? Or I hope to have all the sections opened up hopefully by this weekend, but I've got to switch off to the other class I'm doing tomorrow and update some of their materials too. So we'll be kind of going back and forth a little bit. Questions, comments? Okay, I thought from time to time, what I do on Wednesdays is I like to throw in really kind of bits and pieces that will help you understand why we make certain decisions about certain types of statistics and how we interpret the output and what the output might mean. And so I thought that this would be a good opportunity to talk about something that we talked about earlier briefly, but now we've got some examples that we can look at in terms of why we would do certain things and why we use certain statistics. And so the first piece of that is understand the nature of the types of data that we work with and the limitations that those data present and why we do certain procedures with that different data. And so I had not really done any sort of detailed explanation of that or any sort of detailed review of that. And I want to take just a few minutes, it won't take very long, to talk about that and then talk about how it links up to different types of statistical analysis. And once again, we'll kind of stay within the bounds of what we've done so far or what we're going to do. And hopefully you'll kind of see how those things fit together and how we make those decisions. So I'm going to share up the little overhead thingy. And we'll kind of use that for a moment. Let me reorient my screen here a little bit. Okay. One of the things that we're sort of constantly having to think about is how we collect data and the type of data we collect, or the transformations that we might make to data to answer particular types of questions. And in doing statistical analysis, we generally are trying to answer two types of questions. One of those types of questions is kind of a question having to do with cause and effect. And cause and effect questions are difficult ones to answer, but they're also sometimes the only reason we do a particular piece of research is to come to a conclusion as which might be the best method to use, or the best dosage to use, or the best, whatever it is. We're trying to determine between different comparative pieces to see which is the best. And that's really sort of causal information that we're trying to arrive at. Even though we never really can know causation with 100% accuracy, we can only know to a certain level of probability, because that's all statistics ever tells us, to a certain level of probability. And so we do causal stuff. Well, causal stuff requires us to have particular types of data that represent particular parts of the experiment. And the other type of analysis that we do quite often in statistical analysis is relationship information, in which we're trying to see if different variables might bear some relationship to each other without really sort of thinking about or getting into any notions of causation, but are certain things connected? Are certain things related to each other? And depending upon the type of data we have, we have to pick different techniques of doing that because of sort of limitations to the data. But it all comes back to the types of data that we have collected. And essentially, we collect two types of data. We collect categorical data, which is data that's exactly what it says, that we're placing, we generally use it to do information about what group a person is in, or what type of dosage they have, or what type of treatment they have. And so it's to put people in categories. And if you think about the modern scientific method, one of the things we're doing there is we've got an experimental sample, and we generally have a control sample. Now, it doesn't mean we have to have a control sample. We can have two experimental samples that are just doing different treatments or different dosages or whatever. But they have to be categorical. And so we have to be able to take subjects and put them, identify them by certain categories they're in. Their experimental group or the control group, or in dosage A or dosage B, or whatever it is that defines the category, that's where they are. And it's kind of in some ways a rudimentary sort of data, in that we don't get a lot of fine detail in it. Because if let's say we have a category in which we're saying a certain age is what defines one category from another, and that age is 21. Well, there's no difference then between somebody that's 21 and somebody that's 42. They'd still be in the same category of 21 or over. And say somebody that's 19, that'd be in the same category with somebody that's 3. And yet, if we had two subjects that were 19 and 21, we wouldn't know that they're actually closer than other potential subjects that say are 3 and 42. And so, there's a certain lack of descriptiveness to get categorical data. But in order to determine which groups people are in, or to place people in groups, or some variables, some characteristics like gender, or whether somebody is obese or just overweight, or how much people make in different categories. And you can have multiple categories. Typically, if you have about more than 4 or 5, it gets a little bit, you're kind of figuring out how to make things up a little bit, I think. And so it becomes a little messier the more categories you have. But it's not unusual to have categories, because you want to define people by characteristics, or people by, what particular sample they might be in, or what particular group they might be in. And so categorical data is that kind of data. The other kind of data, to use the technical term, sometimes I just call it continuous data, but it's actually called interval data. Sometimes it'll be referred to as scale data. And so generally the notions of interval or continuous or scale are the same. There's some, fine gradation differences between those three words, what they define, but in general, we consider them all the same. And that's where an individual has a score or has a value that's located somewhere on a scale that's made up of equal interval increments. And so let's say it's a scale of dollars, and it's made up of dollar increments or $1,000 increments or whatever. As long as the increments are identical in value, anywhere they occur along that scale, we would consider it to be an interval scale, and therefore a continuous scale. And the only exception to that is what we call Likert scales, Likert scales, the strongly disagree to strongly agree and things like that. A long time ago, the American Psychological Association, because they needed ways of measuring things that they had defined that really we had no inherent way of measuring, like, intelligence or aptitude or, strength of personality or motivation or, any of those things, moral decision making, all those concepts that psychologists wanted to talk about, wanted to deal with. They didn't have any way of measuring those, because they're not like, inches on a ruler. They're, how do you measure those things? You can't open a little hole up in somebody's mind and say, okay, well, I see your motivation's at, 6.3. And so they had to figure out ways of measuring things using language. But at the same time, they wanted to be able to analyze them using more sophisticated cause and effect measures. And so they kind of came to an agreement that, they would accept Likert scale values as continuous data. And so, maybe strongly agree is 4, and strongly disagree is 1, and 2 and 3 are, agree and disagree. And the actual Likert scale sort of protocol doesn't have a no opinion. And so they don't have a no opinion in the middle. What it does have is non-applicable. Maybe a person doesn't have any experiences that relate to a particular question or something like that. And so the one exception to being pure interval scales is the Likert scale, but Likert scales can also be categorical. If you look at responses by category. And so they became a very viable way of doing things, as long as your definitional terms and questions were actually appropriate for what the concept you're trying to measure. And so that's always the question: what's the validity and the sort of the accuracy of those types of scales? But we use a lot of them, within measuring, human emotions and human motivations and efficacy and all those things. but we treat them just like they're an interval scale, or can. Or we can treat them categorical. Depends on what question we need to answer. And so if you think of most research questions have a sort of even though we're not talking about cause and effect, they have sort of a cause thing, an effect thing, even if we're just talking about the chronology of things. If something, one thing happens before another, that doesn't mean they're cause and effect. But it also means that one of them can be used to predict the other. And so sometimes we're talking about prediction as opposed to cause and effect. So even though, we may be able to say, if you do this, this will happen, does not necessarily mean it's causation. It may be, the chances of you doing those two things at the same time or in sequence is the probability of that occurring is pretty high, but it doesn't necessarily mean they're related. It just means, doesn't mean there's a cause and effect, it just means they're kind of related to each other in some way. And there's another variable or another effect out there somewhere that's that's kind of making both of those things happen. And so if we think in the sort of the rude language of cause and effect, even though it's very crude to think of it that way, generally when we're dealing with certainly in the example of the modern scientific method, the cause variable is almost always categorical, and the effect variable is almost always interval. And so in what you have looked at so far, the only thing that we can really, cause and effect is that's the very language of t-test. Because if we look at independent t-test, we have two categories and some interval scale. And so if we have two categories and an interval scale, and we're wanting to know, which one of is there a significant difference between those two categories and their impact on the interval scale, it's an independent t-test. If we are looking at a paired t, pre-post, we have two pieces of interval data pre-score, post-score, but we also happen to have two categories. Pre and post. So what we're actually doing is we're saying, okay, we want to know, did individuals change between their pre-score and post-score? Individuals, not groups, individuals. And then once we know whether individuals, the extent to which individuals change between pre and post, then we can aggregate all of that and come to a group decision. As a group, is there a significant difference between pre and post? But the way we look at that in terms of two categorical variables, pre and post, and two pieces of interval data, the pre-score and the post-score. And for the one sample t, we have two pieces of interval data One of those, we are looking at two categories actually. One of those categories is the sample mean. And the other category is a population mean. And population means are sometimes referred to as parameters. But all of these things require us first to know what kind of data we're wanting to collect. Now, as you can imagine, and I'm not going to go any deeper into this in this little discussion, as you can imagine, this doesn't encompass all the different types of data setups that we can run into. We could have more than two groups, and we're going to talk about that next. You know, the next session, and after we get past this first evaluation, we'll jump into that both feet. The next iteration is having more than two groups. If you have more than two groups, we can't do any of this. And so we have to do what's called analysis of variance, which will let us make comparisons between more than two groups on one test. It will also let us make decisions about more than one interval variable, multiple interval variables, and multiple independent variables. But the important thing to know is it's more than two groups, and so with more than two groups, we end up with analysis of variance. You can also see that there might be instances in which you have two interval pieces of data and you want to know if they're related. You know, is GPA score, is the SAT score related to GPA? Those are both interval bits of data, but it makes sense to look at that relationship to see if it exists. Is one predictive of the other? And for that, we'll be doing correlation and regression. And it might be possible to, if you think about it, to have two pieces of categorical data. And an example I'll use later in one of the videos, one that I actually worked with, was that there was a school division, a rural school division, that was going through a real political crisis and also a financial crisis, much like today. And they were trying to decide whether they could afford to do athletics. You know, it came down to thinking about, are we doing as much athletics as we're doing? We're going to do less. Can we afford to do athletics as, you know, and use money for that when we probably need to use as much money as we can, as much resources as we can on academics? And so the question was asked, and the point was made, is participation in athletics related to graduation? And if so, in what way? And if you think about it, those are two categorical variables: participation in athletics or not, or graduation or not. And we have a whole family of techniques to work with that, but the simpler ones that we're going to talk about are what's called chi-square. And it's a pure probability sort of thing. And one that's referred to typically as logistic regression. And so we'll kind of pick those things up as we go along, but we'll keep coming back to thinking about what types of variables do we have to answer what types of questions, and based on the variables, what types of analysis do we need to use, and how can we interpret that? And so I'll keep kind of picking at this a little bit as we go along, assuming that you're going to be looking at some of the videos in which I'm introducing these techniques, like the video for ANOVA, correlation, and regression. I've got all three of those in one video. is already up. And so you can begin to think about that. And of course, you've got that online stats book with a very easy index to follow on that. You can always, pick up some reads there. And so if you have, if you have questions beyond that point, we'll deal with them. But, the intent was to make this as much 100% online as possible and as much asynchronous as possible. And so that's the reason for all the material going up online. Okay, any questions about this? All right. So, where are we? Are you, well, where we are, so we're about a month from the end of this thing. So we got to kind of pick up the flow here a little bit. But it's pretty straightforward, pretty easy. I'll also be adding a few little enhancements online in terms of some techniques and readings that tend to be a bit more useful for the medical fields. And I know it's kind of a tough time for the medical fields right now, but at the same time, it's also a time in which it's important to know, what the research is telling you and how much stock to put in that. And that's why, sort of understanding some of these little related concepts are important pieces. Any questions?
I had a quick question, Dr. Bolt, with regard to the first evaluation, where you, my understanding is you want us to answer these questions as well as copy and paste. Once we run our statistics in JASP, you want us to copy and paste the table that we from, in addition to
the answer. Yes.
What we pulled out of it. Okay. Thank you.
It's a little bit easier to pick up where you may have made a mistake if I can see what you were reading. Yeah. Other questions? I'm not going anywhere. Feel free to, throw anything at me whenever it comes up, whether it's tonight or whenever. I'll respond to, short of telling you exactly what the answer is, I'll respond to pretty much any question you ask, even questions about, am I doing the right technique here and things like that. But wait until you get stuck first. Don't start with question one and say, okay, am I doing the right thing here? No. Wait until you get stuck, and then we'll deal with that. And remember, these everything that happened to the final exam, final evaluation piece is these are all formative. That's the only thing they're there for, is to kind of point out what you should be coming up with versus what you came up with, and how'd you get there, and let's talk about it in other ways. Unlike some math, and stats is not math, but unlike some math, there typically aren't multiple ways of getting there. There's typically the very best, and then there might be an alternative, but it's not as accurate as the very best. And so, in math, there's many different ways of getting there. I mean, one thing we didn't know about kids in math is that everybody's brain works kind of in different patterns, and some people do it with estimation, some people do it with place holding. I mean, there's all kinds of reasons that people reach certain answers in math, and they can all be correct. It's just that some work differently for some people, and that's something we need math teachers to learn too, is that there's all different sorts of ways of doing things. Unfortunately, in stats, we don't have as much leeway. There's a couple different ways of interpreting, of evaluating a whole bunch of things, but one of them is better than the other, typically. Other thoughts, questions?
Dr. Bolt?
Yo.
I missed the first few minutes. Are we going to be using the same data set that you had given us once before, or is there another data set you want us to
data
download?
set for the evaluation will be coming up. Yeah, it's up. It's already posted up. Yeah.
Okay, thank you.
There'll be a different, in most cases, a different data set all the way through, but you know, I'll carry some data elements through from beginning to end and just add more cases or, you know, convert the data a little bit for different purposes. Yeah.
Okay, thank you.
Other? All right, folks. Have a great 4th. Take care of yourself. Be safe. You know, we don't need anybody coming in with a big bandage wrapped around our hand or something like that. And so, you know, stay away from things that you're not supposed to be near. and it might be good to stay away from people too, you know, close relatives accepted, you know, that you live with or whatever, but, you know, fewer people are around, I think these days maybe the better. And, but be safe and take it easy and have a good 4th. And
Thank you.
You see you
as
next week.
well.
Yeah. Thank you. Good night, folks.
Thank you.
Good night, sir. Thank you.
Thanks.